Good afternoon, everybody. My name is Emanuel Lima, and I'm going to talk to you guys about cadCAD, a work-in-progress modeling library for generalized dynamical systems. So this is just a little bit about me. I am a research software engineer at BlockScience, and I am the lead engineer for cadCAD. So first of all, what is cadCAD? So basically, cadCAD stands for Complex Adaptive Dynamics Computer-Aided Design. And that is just a mouthful for saying that cadCAD is an open source framework for generalized dynamical system. And what we are working on right now, the effort that is more advanced, is our reference implementation in Python, but we are also working on other implementations in other languages such as Julia, for example. So basically, what is a dynamical system? Dynamical system is the mathematical representation of an observed phenomena that has a certain state, that is the snapshot of the attributes of a system, and rules about the time evolution of that system. And that dynamical system comes in various flavors, like for example, the one that we have in this equation here is a time discrete dynamical system. But then we went a step forward, and now we have generalized dynamical systems, that basically, instead of having a system that involves basically a real number or a set of real numbers, now we have a generalized version of that theory that deals with the evolving of a generic data record. And for example, that you can see on this type 3 here, the data record can have any kind of types that one may want, so you are not stuck to floats, basically. And so that was the first, this is the first main concept of cadCAD. So you can have the data records, and those data records we call spaces. The second main concept in cadCAD and in GDS is the concept of a block. So basically the block is the main logic that is going to say how the system is going to evolve over time. And those blocks are those gray boxes on this diagram here. And you can see that we can make them together or join them according to their domains and codomains, the colored circles, and we can put them together like Legos. So you can make an arbitrarily complex wiring of blocks, or rather wiring of logics, to have an arbitrarily complex time evolution of a system or of a generic data record, basically. And all of that goes back to those three small concepts here. So the first one is tearing. So if I look at this diagram here, I can look at the whole diagram and just look at it all as the same, just one big block or just one big logic. Or I can tear this one big logic into their small constituents that are those small gray boxes, and that's the process of tearing. And then there is the process of zooming, where I am concerned only with the internal logic of each of those gray boxes, and I want to model only the gray boxes. And the process of linking, that is the process of joining each of those blocks together, because basically the output of one of those blocks has to be the same as the input of the next block. So by doing that, I can make like arbitrarily long pipelines or wires of data transformations for those data records that I just showed. So basically, our main motivation for doing cadCAD was systems engineers and mechanism designers were using like very expensive proprietary software for modeling, and we wanted to have an open source alternative for it. And this is just a little bit of the syntax that one can use to make those wires in cadCAD. So the space is a decorator over a class that says the data record. The block is a decorator over a regular Python function that says the logic of the time evolution of the system. And then you have some small boilerplate to create the experiment, run the experiment, and then you can produce, for example, in this small example, this random walk. That's just a chaotic dynamical system. And this is just some pointers, some links in case you guys want to learn more, and in case you guys want to check out our progress. We are at github.com/cadcad.org/cadcad. Thank you very much.